Hello everyone, today I'm going to talk about rationalizing the denominator. So in rationalizing the denominator, whenever you have a fraction, the denominator always has a radical. So when it has a radical, all you need to do is multiply it with the radical, the denominator and the numerator. And the answer is going to be if you multiply a by square root of b, it's obviously going to be a square root of b. So if you multiply square root of b to square root of b, it would be b squared, which will cancel the radical. So let's give you a proper example. So now we have 2, the square root of 7. A 7 is not a perfect square. So we have to multiply square root of 7 with square root of 7 and 2 with also square root of 7. If you multiply 2 with square root of 7, the answer is going to be 2 square root of 7. If you multiply 7 square root of 7, it's going to be 7. Because if you multiply 7 by 7, it's going to be If you multiply 7 by 7, it's going to be 49. And the square root of 49 is 7. But you do that when it's not a perfect square. But what happens when we have a perfect square? It's just simple. So over here, the denominator is a perfect square. So you just simplify it. It's just easy as that. And that is the first example.
Cut.
So my second example is rationalizing the denominator with a radical in numerator and denominator. So my first example, the denominator has a radical. But in this example, the numerator also has a radical. So you simply just find square root of both the numerator and the denominator. So I'm going to give you the proper example again. So the square root of 3 over the square root of 5. So you multiply the denominator with its radical, the square root of 5. You also multiply the numerator with the radical. So after that, 3 times 5 is 15. So we put square root of 15. If it's not a perfect square, just leave it as is. And 5 times 5 is 25, and the square root of 25 is 5. It's just as simple as that. Okay, my third example is rationalizing the denominator with a radical in the numerator and the denominator. It's also like the other example, but it has a twist. Now this might take you a while because this is a longer equation. So let's start. Whenever you have a numerator that has this, you always get the conjugate. The conjugate of 2 minus square root of 3 is 2 plus square root of 3. So on the numerator, you also multiply the conjugate of the denominator. Now after that, we distribute. So 5 times 2 is going to be 10, and 5 times the square root of 3 is going to be positive 5 square root of 3. After that, we distribute all of them. Square root of 3 times 2 is 2, positive 2 times the square root of 3, and the square root of 3 times the square root of 3 is the square root of 9. I'm going to simplify this later, but let me just continue. Now we move on to the denominator. The 2 times 2 is 4. 2 times the square root of 3 is positive 2 square root of 3. Now, negative square root of 3 times 2 is negative 2 the square root of 3, and negative square root of 3 times positive square root of 3 is going to be negative square root of 9. So now, this is obviously not the final answer, so let us just simplify this. So as you can see here in the numerator, the middle, both of these has the same radical, so we can solve them. So 5 plus 2, oh wait, let's just put 10 first. Now, 5 plus 2 is 7, positive 7, and you don't move the radical, it just stays the same. Now, square root of 9 is 3, positive 3. Now, here in the denominator, we also have that. We have the same radicals, so we can also solve them. So 2 minus 2 is 0, so we already canceled that. And so it's going to be 4, and the square root of negative square root of 9 is going to be negative 3. So, after that, we add 10 with 3. It's going to be 13. And plus 7 square root of 3. Now, 4 minus 3 is 1. But it can also be just 13 plus 7 square root of 3. Okay, now, with my fourth example, rationalize the denominator with a radical. Let's just go back to basics for a second because later it's going to be pretty complicated. So, over here's my example. Over 2 square root of 2. So, this is my example. So, again, we just multiply with the numerator and the denominator with the radical of the denominator. So, square root of 2 and the square root of 2. Now, we multiply the square root of 12 with 2, which is 8 square root of 24. Now, the denominator. Square root of 2 times the square root of 2 is 2 square root of 4, but 4 is a perfect square. So, it can also be 2. So, 2 times 2, which is 4. We remove this, just change it to 4, so we can save some space. Now, this is not the final answer because you can simplify this. So, if you divide 8 by 4, the answer is going to be 2 square root of 24. Now, again, this is not the final answer because even though 24 is not a perfect square, you can still find factors that is a perfect square. So, if you multiply, let's say, 4 and 6, that's the answer is 24. But 4 here is a perfect square. So, we can 2 times 2 square root of 6. We remove the 4 and multiply it with the number out here. The answer is going to be 4 square root of 6. fifth example. Rationalize the denominator with two radicals in the denominator. So, here's my example. Over 3 squared of 3 plus 6 squared of 2. It's just like my other examples, but the denominator now has two radicals. So, what we do is, we just always get the conjugate of the denominator. So, multiply this, the conjugate, 3 square root of 3 minus 6 square root of 2. Now, we also multiply the conjugate of the denominator with the numerator. So, 3 square root of 3 minus 6 square root of 2. Now, we just distribute square root of 11 times 3 square root of 3 is going to be 3 square root of 33, because 11 times 3 is 33. Now, square root of 11 times negative 6 square root of 2 is going to be negative 6 square root of 22, because square root of 11 times 2 is 22. Now we move on to the denominator. Now, we just multiply 3 square root of 3 with also 3 square root of 3 and 6 square root of 2 with negative 6 square root of 2. So, 3 square root of 3 times 3 square root of 3 is going to be 9, because 3 times is 9, and square root of 9. I'm also gonna simplify this later, but let's just move on. Now, 6 square root of 2 times the negative 6 square root of 2 is going to be negative 36. 2 times 3 is 6. So, square root of 6. Wait, I'm sorry. It's 4. So now, we simplify this. So let's just move it over here. 3 square root of 33 minus 6 square root of 22 over 9 times 3, because square root of 9 is 3, and minus 36 times 2, because the square root of 4 is 2. Now, 9 times 3 is 27. So, over 27. And 36 times 2 is 72. So, we put minus 72. Let's also remove this to save time. So now, when we got this, we also simplify this. 27 minus 72 is negative 45. So now, when you have this is not yet the final answer, because we have to split it. So over here, we have 3 square root of 33 over negative 45 minus 6 square root of 22 over negative 45. Now, we can simplify this because 45 is divisible by 3. So now, negative 45 divided by 3 is 15. Oh, wait, yeah. We put the negative up here, 33 over, and we put 15 here. Now, even though 45 isn't divisible by 6, you can just divide it by 3. So 6 divided by 3 is 2, and 45 divided by 3 is also 15. And this is the final answer. And that is my topic about rationalizing the denominator. Thank you for watching.